Okay, Assalamualaikum and hi everyone. My name is Muhammad Azizam Salifin and I'm from Polytechnic Kuching Sarawak. Today, I want to show you guys what is reinforced concrete design. Okay, next. Okay, this is table of content which is divided by 4 parts. Part 1 is definition of reinforced concrete. Part 2, the importance of RC design. Part 3, example of process reinforced design of the building. And part 4 is the concept of RC design. Next. Okay, part 1, definition of reinforced concrete. Reinforced concrete is concrete in which steel is embedded in such a manner and the two of material acts together in resistance force. The reinforced steel, rod, bar or mesh absorb the tensile, shear and sometimes the compressive stress in a concrete structure. Plain concrete does not easily withstand tensile and shear stress caused by wind, earthquakes, vibration and other force is therefore unsuitable in most structural applications. In reinforced concrete, the tensile strength of steel and the compressive strength of concrete work together to allow the member to sustain the stresses over the considerable span. The invention of reinforced concrete in the 19th century revolutionized the construction industry, and concrete became one of the world's most common building material. Okay, next. Okay, part 2. The importance of RC. A fundamental importance of reinforced concrete design is bond strength between the concrete and the reinforced steel. It's crucial that tensile stress can be transferred from concrete to its reinforced steel, otherwise failure can occur. The concrete cover over the reinforcing steel is essential. Concrete cover over the reinforcing steel essential for ensuring the bond strength between concrete and steel. Increased concrete also improve the bond strength and slip resistance between the material. Next. Okay, this is part 3. Example of cross reinforcement concrete design of the building. First image is you can see the construction of the column, and the second image you can see the construction of the slab. Next. Okay, this is the last part, the concept of RC design. During the process of RC design, we as a student are required to follow the steps and formula based on the lecture note and also by referring the reinforced concrete design to Eurocode 2. Okay, this is the cover of books. Okay. There are 3 important things need to highlight when designing reinforced concrete based on our level. Where is design of slab, B, design of beam, and the last one is design of column. Next. Okay, slab. A concrete slab is a common structural element of the modern building, consisting of a flat horizontal surface made of cast concrete. Steel reinforced slab, typically between 100 and 500 mm thick, are the most often used construct floor and ceiling, while thinner mud slab may be used for exterior paving. Type of slab. There are 2 types of slab, which is one-way slab and two-way slab. Okay. One-way slab is supported by beam on the two opposite sides to carry the load along one direction. The ratio of the longest span to shortest span is below than 2. Such slab slab bend in direction along its shortest span. Main reinforcement provided in shorter span and distribution reinforcement is provided in longer span. Distribution bar are cranked to resist the formation of stress. Okay, two-way slab. Two-way slab are supported on all sides. Slab on beam suitable for span between 6 to 9 meter and live load 3 to 6 kN per M2. The reinforcement in both directions increase the stiffness of the slab, producing relatively low deflection. Additional formwork for the primary and secondary beam is needed. Basic requirement design slab. Specification and slab thickness. You can refer table 1.5 for permanent action GK. Refer table 1.6 for variable action QK. Refer table 1.3 for design life. Refer table 1.4 for exposed classes. And the last one, you can refer 5.5 for fire resistant. Basic requirement designing slab. Durability. Basic requirement designing slab. Durability, fire and bond resistant. You can refer table 5.5, which is C-min and C-min duration. Refer table 5.4 for min requirement exit distance. And you can determine C-min and C-def and dominant cover by okay, next. Basic requirement for designing slab. Action and analysis. Calculate the value of design action, moment negative and positive at short and long span. Calculate the value by repairing the formula. Determine the number of bar, the size, and it must be longer or bigger than actual calculate. Okay, thank you.